when you ran zoom 9, you got this, or something like this.
Yeah.
Yeah. So I entered the data in L3 and L4, and then I hit zoom 9, and that's what I got, which is...
Oh, I got that. Hey.
Yeah, I got that.
Damn it.
Now you... No. That's what the TI... That's the TI's zoom stat command right there, right? That's the zoom stat command. I don't want that. I don't want zoom 9. What I want is I want to go to the window and look at what it did. Now, look at what it's decided. It decided the x min is 2 and the x max is 22. What is x in our data here? The number of pips. So why is it scaling the x scale at 10? I don't know. Let's make it be 1. Because ours go 2, 3, 4, 5. The difference is 1, yes? Let's make that be 1.
Why is it all the way to 2?
Because it has the scale set at 10. And it goes 2 to 10, and then 11 to 21, and then it gives you a 1 extra. It always pads it. We'll come back to that, why that's in a second, right? Now if you press graph, you get a beautiful little graph. Unfortunately, it's all shoved into one corner. This goes back to Riley's concern about why it was 22. Again, finagle. Window. You see that 22? That's ridiculous. What should it be?
12.
Logically 12, but watch what happens when you put 12 in. Watch what happens when you put 12 in.
There you go.
Do you notice anything missing?
The last one.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It cut 12 off. You always have to get in the habit of giving it one more because of the way the TI counts. It puts the value at the far left side, not the far right side. So make it 13, then press graph, and you'll see your 12. Is that fair?
Yep.
Good. Now, I still want to finagle it. It's okay with you guys. Because all that, this gap here, too much gap. Too much gap. I'm going to change my Y max to...
0.25.
I think 0.25 is a good. I like 0.2, 0.25, somewhere in there. Ooh! 0.25 is too tall. It's hitting the box plots.
Yeah, but it's at the bottom of it.
Oh, but you made the Y min 0, didn't you?
Yes.
Good for you, Randall. There we go. Look at that. That's sharp. I like that. Thank you, sir.
You sure you did it again?
Of course! Actually, that's what Randall did. I was just parroting him. So I changed these guys here, Sandy. We made the horizontal axis be the bottom of the graph, and then we increment it by 0.25. I like when Randall picked 0.25 because what is on the y-axis of this graph? What's on the y-axis?
The most is like 6.
The theoretical probabilities, and the highest one is 1/6 because it's tight, which is 0.166666. So make it taller than that. 0.25 is bigger than 0.17. 0.25 gives you wiggle room. Is that fair? So, I love when you guys said, oh, it should be a bell curve. It's actually not a bell curve, it's a perfect triangle. It's a perfect triangle. It's a 90-degree angled triangle. 45, 45, 90 up top. So it's symmetric. I think what you guys mean is it's a symmetric distribution. It is that. By all means, it is definitely symmetric. It's not a bell curve, though. It's bell-ish. It's close enough to bellish to be like, you can call it a bell curve, but it's not actually a bell curve. It's actually theoretically what's called an absolute value curve. Now, interestingly enough, look what Excel has been doing while you've been hard at work. How do those numbers compare to your theoretical probabilities?
Decently.
What's that? So pretty? Is that what you said? It is very pretty, I think. Now, first of all, I want you to notice something. These are the two dice that are being individually rolled down here. Do they look familiar?
Yes.
Uh-huh, the 1 and 6. The way this Excel sheet is stacked up, it's rolling individual dice and then adding them together. I'm not... Say that again, Riley. It is exactly what you did. What it's not doing is rolling one 11-sided die. Right?
That would make a huge...
That would make a... Why, Faith? Giving me goosebumps just thinking about this. The fact that you said that means it would be what?
1 and 11.
Oh, you make me so proud. No, 1 and 11. You were right the first time. 1 and 11. You make me so proud. But that's not what happens when you roll 2 dice. When you roll 2 dice, as Riley pointed out, the results near the middle are more likely. What happens when you roll 3 dice? Oh, sweet Jesus. Let's do that tomorrow, yeah?
Yeah.
We'll save the coin, too, because we're out of time, unfortunately. Damn it, I want to gamble more.
Yeah.
But that's okay, we'll gamble on Wednesday. Yeah! Yeah, me too! Okay, we'll see you guys on Wednesday. Don't forget the project. That's okay. You can laugh. It's okay. Can you just return all the props? We got the dice go here. And And there's a bag for the coins somewhere, I think. I think I hear it. There it is. Good, good, good. Who knows?
I was rolling 4 dice.
You were?
Four, yeah.
You weren't.